Hello, everyone. Welcome to the third workshop of the ICP Chain Fusion Bitcoin Edition Educate series. Today, we will be hearing from Bob Bodily, co-founder and CEO of TonicLabs, on developing on Ordinal's marketplace.
So I'm Bob Bodily, CEO of Bionic. Bionic is a Bitcoin NFT marketplace. They call those Ordinals. And we built it, Bionic, we built it on ICP. That's the Internet Computer Protocol. And so we've been building blockchain tech as a company for the last 3 years. We started building in 2021, May of 2021. And we have built a whole bunch of tech. We've built NFT marketplace, we've built a wallet, we've built NFT collateralized lending protocol, we've built smart contract wallet, we've built Ordinals tech, Ordinals bridge, leveraging the threshold signing on ICP. So we started building on Bitcoin in January of 2023, specifically leveraging ICP as a Bitcoin sidechain. ICP has a lot of really great Bitcoin primitives. There's a Bitcoin Light node running fully on chain. You can sign Bitcoin transactions directly from an ICP smart contract using the threshold signing subnets, which is really nice. And then you can also bridge Bitcoin, Ordinals, and Runes to ICP directly in order to leverage the programmability on ICP for Bitcoin assets. So Bitcoin is ICP is a really great Bitcoin layer. And you can do lots of interesting things to solve Bitcoin problems on ICP. So that's a little bit about where we are. Recently I've been thinking a lot about interoperability and how we can kind of, expand what we built on Bionic into the kind of layer 0 realm. Layer 0 is like an interoperability protocol that lets you, interact across blockchains. So we've been pushing a little bit on the infrastructure side so that we can get to a good place where we can be more of a cross-chain marketplace and for fungible tokens as well. So that's a bit about my history. And I do a lot of technical content. If you haven't seen, I'm just at Bob Bodily on Twitter. I do all kinds of technical Bitcoin content, talking about how, talking about kind of the new Bitcoin season 2, the renaissance that we've been seeing on Bitcoin over the last 18 months. So that's a little bit about me. Okay, I like my presentations to be a little bit more interactive. I want to target the content that you all want to hear. And I think that's a lot better than just me sage on a stage, just kind of throwing stuff at you. So drop in the chat or maybe even ask a question. Do you have any questions about Chain Fusion or about ICP or about Bitcoin or about leveraging Bitcoin on ICP or building Bitcoin apps on ICP or Ordinals or BRC20 or Runes or layer 2s on Bitcoin. We can go, there are a million different directions we can go. Time is not unlimited. And so would love to focus kind of where you all would like to focus. So if you have questions, drop them in the questions and we can target those. If you have specific content areas you want to cover, drop those in the chat and I can cover those as well. Let's see. Looks like we have another join from Abu Dhabi. Welcome. And it looks like someone was building for the UNODC Knowledge Foundation Hackathon. So that's cool. All right, using AI on ICP. Let's chat through that really quick. So a lot of people are deploying LLMs directly on ICP. This is pretty fantastic because if you wanted to do any fine tuning or if you wanted a reliable kind of replicated source to actually call an LLM, you can deploy an LLM in a smart contract on ICP. and then you can call it directly from your front end. So you have some guarantees on model execution. I know there are a couple of teams right now doing really interesting things. One team is doing face recognition. I think it's off chain right now, but working on bringing it on chain. I know another team that just got GPT-2 to deploy and run inside of a canister, which is really exciting. And I know there's another team working on the C++ side. On the C++ side, I think it's the ICPP group that deployed the Tiny Stories LLM directly into a canister. In fact, they fine-tuned the Tiny Stories LLM and used CKBTC and ICP as their like training set, and then they did a fine-tuned Tiny Stories LLM, and now we're going to actually bake that into an NFT collection. So it'll be an AI powered NFT where the AI will be this immutably deployed canister running on ICP, and then the NFT will call into that AI, and then essentially it'll write this little storybook. It'll start with a prompt and an image, and it'll kind of the write a little story for you. If you don't like the story, you just regenerate it. Once you like it, then you can just keep it and go to the next page, and you'll have like 10 pages in your book. You'll essentially be able to generate your own storybook NFT, and then that's your NFT, and then you can trade it on the marketplace. I mean, you can do whatever you want with the storybook. So, pretty interesting use case for AI on ICP. Let's see if I can find the GPT-2 link. I know I saw someone announce it recently. Looks like if you just Google it, there are a number of, looks like it was Decide AI that was able to get it running. So I'll just drop this Twitter link in the, so that's the link to the GPT-2 AI on ICP. The Decide AI team is pretty great. Okay, that's a little bit on the AI side. Another question, core logic of ordinals and how it works. Okay, so ordinals is NFTs on Bitcoin. Most NFTs, if you look at like Ethereum, there are only a few collections that are 100% on chain, meaning the image asset is on chain and the metadata is on chain, all in the smart contract. It's not very common on Ethereum because it's so expensive to store data on chain. And so people have had to be very efficient about how they store data on chain. So instead of that, they'll store images in IPFS, and then they'll just include a link to the image in the smart contract itself. This gives you a little bit of a lesser security, perhaps, because your image isn't on chain. IPFS links are known to, break or go away. If you're not pinning the content yourself on IPFS and no one is kind of regularly looking at it, then it could get just forgotten and not indexed anymore on the IPFS side. So on Bitcoin, people are actually storing everything on chain on Bitcoin. So in a Bitcoin transaction, there's a section called the witness data. It's generally for signatures and other data, but it's actually cheaper to store data in the witness section than it is to store data in just a normal Bitcoin transaction. So people take the bytes of an image and they store it in the witness of a Bitcoin transaction. And then they connect that image asset to the first Satoshi in the output. You have to know a little bit about Bitcoin. Bitcoin is fungible to 8 decimal places, and the smallest unit of a Bitcoin. So one Bitcoin has 100 million Satoshis, which means one Satoshi is, there are 100 million Satoshis in a single Bitcoin. And the first, if you can actually track these Satoshis from when they were minted until the present day, using like a FIFO strategy, first in, first out. So when sats are minted, you have like 50K Bitcoin that goes to a certain address, and they all have an associated number, and then you track those numbers as they go throughout all of the UTXOs. And now you've essentially made Bitcoin non-fungible in a way, because now every single Satoshi in Bitcoin has a unique number. Once you do that, then you can associate this particular image that we stored in the witness data in Bitcoin to an individual unique Satoshi based on its number. And that image is, forever associated with the first sat um, of this output. And that's how ordinals work. Now you have a single sat of Bitcoin. I mean, it's just Bitcoin. It's just a single Satoshi of Bitcoin that is now connected to an image asset, and that is an NFT or a digital artifact or an ordinal on Bitcoin. So this is how people are doing NFTs on Bitcoin. You have the full security and decentralization of Bitcoin for your image assets as well as your token. And then there's an off-chain indexer. And this indexer essentially reads through the Bitcoin blockchain. And whenever it finds one of these images that have been marked appropriately, it indexes that as, oh, we have another ordinal. Here's the image, here's where it's stored, here's the Satoshi number, etc. The nice thing about this is ordinals are just Bitcoin. It's just a single Satoshi of Bitcoin. And so if you want to bridge ordinals, you basically just tell them, okay, you have a UTXO. A UTXO is going to have a lot of sats in it, but the first sat is going to be connected to your ordinal. And then you just lock up this UTXO on ICP, and then we mint you a corresponding token on the Bionic side. So that's how we do ordinals bridging. People just come in, take a UTXO, lock it up in a unique address, and then they get a token that they can trade on Bionic. So the benefit of Bionic is that you can trade ordinals at the speed and cost of ICP rather than the speed and cost of Bitcoin. Bitcoin, it's going to take $1 to $5 to $10 for a single transaction, depending on the network fees. And you're going to have, I don't know, 10-minute to 60-minute block times, averaging probably 10 minutes. On ICP, you get 5-second transactions, and the fee is always just 10 sats. So it's cheaper, and you can trade faster. It's just kind of a better user experience. And so this is what we've been doing with Bionic, building an ordinals marketplace on ICP. Okay, good question. Why did it take so long for NFTs to develop on Bitcoin when they have been around for a while on Ethereum, Solana? So it's funny, but NFTs were actually created on Bitcoin first. Bitcoin is the whatever, the father chain, the grandfather, the mother of NFTs. If you go back to the counterparty days, 2014, we already had images being stored on Bitcoin directly. Counterparty uses, there are a couple different places to store data on Bitcoin. One is the witness data, that's what Ordinals uses, that's what BRC20 uses, but another one is the op return, and another one is you can actually use a series of fake multi-sig transactions. What I mean by fake multi-sig is they're not real Bitcoin addresses. You can basically just take arbitrary data, and as long as it starts with the right prefix and ends with the right suffix, it looks like a Bitcoin address, but it's actually image data encoded into a fake Bitcoin address. So you can do this 2 of 3 multi-sig scheme where you can actually store image data in a Bitcoin transaction. So, since 2014, we've had NFTs on Bitcoin. And so why has it taken so long? I have no idea. I mean, Counterparty never really got traction. Maybe it was because you had to burn Bitcoin to get XCP. That's the Counterparty token. And people didn't like burning Bitcoin. Maybe people hated the Counterparty had a token. They did start. There is a Counterparty token that you need to kind of interact on the metaprotocol. And so for whatever reason, it didn't really take off. And then we had, NFTs going crazy on Ethereum. I mean, first with CryptoKitties, and then with a whole bunch of other projects, and then we had NFT Summer of 2021. Then we had this like slow bleed, 2022, 2023, until January, and that's when Casey Rodamore released Ordinals. And I don't know what it was. Like people were looking for something shiny. Casey did a really good job. People have always wanted to come back to Bitcoin. Whatever it was, like being able to hold things in a wallet and like transact, it was just so native, so analogous to what had happened on Ethereum, except now it was on Bitcoin. And so for whatever reason, I mean, that spurred Bitcoin Season 2. Now we have, I don't know, hundreds of meta protocols and side chains and layer 2s and projects building on Bitcoin. Probably more people building on Bitcoin than we've ever had building on Bitcoin ever. So I'm calling, people call this a renaissance, Bitcoin season 2, whatever you want to call it. Let's see. How do the image bytes fit into the transaction witness data? So there isn't really a limit on how big you can make the witness data. The witness data is just a section. Mempools don't pass on. So the way the Bitcoin mempool works, every node has a mempool. And when you submit a transaction, you hit one node and it goes in that node's mempool, and then it shares to other nodes, and then it gets in other, the miners' mempools, and then the miners can actually mine your transactions. So there's this like gossip network where all the nodes are talking to each other. They won't pass on transactions that are bigger than 400 kilobytes. And so you are limited to size. Your image has to be smaller than 400 kilobytes. That's if you want it to be propagated through and actually get mined using normal consensus. That's because if it's bigger than 400 kilobytes, it doesn't fit in what's called the standardness rules. The standardness rules are a set of rules basically governing the nodes. It's not part of the core consensus protocol, but it's what nodes use to kind of like prevent spam and things like that on the network. And so um, as long as your image is smaller than the 400 kilobytes, then you're good to go essentially, and you can pay your transaction fee. You're gonna have to pay to put 400 kilobytes on Bitcoin, which is gonna be what, like a couple $1,000 maybe. And so it's kind of expensive. So you want to keep assets really really small. Um, if you wanted to, there are a couple of people who have gone directly to miners to avoid this 400 kilobyte limit, and you can actually go up to the full block size, which is 4 megabytes. And so there are, a handful of people that have actually done 4 megabyte assets directly on Bitcoin. Basically, they took up the entirety of a block. All 4 megabytes was devoted to a single asset. So to do that, you basically work directly with the miner and you say, hey, miner, I'll give you $20,000 if you mine my transaction instead of the 20K that you're going to get by mining all of the Bitcoin transactions currently in the mempool. And the miner says, oh, okay, well, give me 30K because that's a better deal for me. And then you say, okay, and then they'll mine your transaction instead of all the transactions in the mempool. Bitcoin miner can technically mine whatever they want, but they're financially incentivized to mine the highest fee paying transactions because they need to make revenue in order to cover their costs. So that there are some significant limitations to storing image data on Bitcoin, and not everything is going to fit on Bitcoin, but a lot of things are going to fit on Bitcoin. Um, so that's a little bit of a deeper dive there on ordinals, where data is stored, how it works, how bridging works with Bionic, etc. What else do we have? So is it better to store it on ICP and store an ID on Bitcoin? So it depends on what you're going for here. If you can create small assets, like a lot of people are innovating on how to create small assets. So whether it's small pixel artwork, 64 by 64 pixels, that works well on Bitcoin, especially if it's generative. So you only inscribe the layers to Bitcoin rather than like all 10,000 assets in a collection. A lot of people are doing SVG. SVG is smaller, and so SVG is a nice file format. A lot of people are also programmatically generating their artwork. So there are libraries like 3JS or P5JS that have been already inscribed to Bitcoin, and you can just leverage those libraries right now. So you could build a really cool artwork just leveraging code in 3JS, and it's going to be really, really small because you don't actually have to render the image. You're programmatically generating the image. And so there are a lot of people doing these kinds of innovative things to try to decrease their asset size and make it a lot better to store things on Bitcoin, which is cool. And there's a lot of innovation happening there. That doesn't work for everything. And for things that it doesn't work for, then you're going to have to store your image data somewhere else. And so we do have this hybrid storage model on Bionic. Hybrid storage meaning you store assets on ICP essentially, and then you store a hash or a pointer or a smaller, more Bitcoin optimized representative asset on Bitcoin itself. Essentially with a pointer back to the higher res asset on ICP. So I think this hybrid model is a really good path for a lot of people that have, I don't know, really big music files or big 3D files or big video files, or even just like really high res artwork or things like that. I think this hybrid storage model is pretty promising, and we've seen some traction there from creators wanting to come in and store things more affordably on another chain like ICP, and then still have something inscribed to Bitcoin directly as an ordinal. So hybrid storage is pretty interesting. Documentation on hybrid logic on Bionic. We don't have any documentation on that. If you want more info, feel free to just reach out. I'm happy to chat. I'm just at Bob Bodily on Twitter. You can DM me or Telegram. I'm at Bob Bodily everywhere. So you're welcome to reach out, and I can chat more about the hybrid storage model. Okay, kind of touched on historical sats. We could also talk about rare sats. Do you think these are legit / worth seeking out? What are your thoughts? So every sat, if you track it throughout time, now has a history associated with it. There's a number associated with your Satoshi. There's a name. Essentially, you can convert the number into a alpha, like a character based, letters based version of the number. So you have a name and you have a number, but you also have a history, and so you have the pizza, the famous Bitcoin pizza transaction. There are pizza sats. These are called pizza sats. There are uncommon sats. This is the first sat in a block. You also have like a black sat, which is the last sat of a block. You have other things like palindrome sats, if the number is a palindrome, or you have sats that were involved in Mount Gox, or sats that were involved with various, historically significant transactions, or maybe the sat was mined on your birthday or on your wedding day or on your kids' birthdays. And so there's a lot of meaning kind of imbued in these individual Satoshis. And so a lot of people like to collect various Satoshi types. There is a challenge where, I mean, you can slice and dice Bitcoin sats however you want. I mean, I could create 1,000 different categories. And you start overlapping categories, and all of a sudden it's like, oh, there are only 10 sats in the entire Bitcoin supply that are palindrome pizza sats that were also, mined in January or something like that. Like, you can create arbitrarily complex categories that make it rare. Does that mean it's meaningful? No. And a lot of the rare sats are actually quite plentiful, to the point where like everyone on Earth could have 300 of the sats, or something like that. And so I think rare sats are valuable in as much as they have meaning to the buyer, to the holder. A lot of people are trying to collect like the first rare sats ever, like the block 9 450x is one that a lot of people talk about. It just depends on what you value as a collector. If you want to collect historical sats, the oldest sats that we have right now, I think you can collect them, and I think it makes sense. It's like collecting coins, essentially. I haven't done a lot of rare sat collecting personally, partly because I just don't have a lot of time to degen on crazy Bitcoin things. But I think rare sats there do have some provenance associated with them. Like, I know Trevor with the Pizza Ninjas did a lot of work with the pizza sats, and that's just like a really it just makes sense for that collection to happen on pizza sats. And so I think my answer is find meaning in sats that you care about, and then they will be valuable to you, at least. And if you're just collecting the things that you love, then who cares who else thinks it's valuable? They may or may not be valuable in the future. I have no idea. Okay, what else do we have? I think we're getting pretty close to time. I think we were just targeting 30 minutes here, I believe. Or is this an hour? Maybe it's an hour. I think we might have an hour. What other questions do we have from your explanations are very clear. Well, thank you. Can you explain the difference between runes and ordinals? Sure. Okay, runes are a fungible token protocol. Ordinals are a non-fungible token protocol. So runes are tokens, ordinals are NFTs. There are also some additional differences. Runes are stored in the op return of a Bitcoin transaction. Workshop is 1 hour. Perfect. We got 30 more minutes. Um, Runes are stored in the op return, which is just a different place to store data in a Bitcoin transaction. Ordinals are stored in the witness data. And then BRC20 is a fungible token standard, the first fungible token standard on Bitcoin Season 2, let's say. Technically, Counterparty is a fungible token standard. But BRC20 launched on the Ordinals protocol, and BRC20 stores their transaction data in the witness data as well as Ordinals, because BRC20 is actually built on top of Ordinals. Runes is not built on Ordinals, it's directly in the op return. Runes was built by Casey Rottermore, uh, and it's a very efficient implementation. So you have a really nice encoding. You have, very succinct kinds of representations for how you deploy tokens or mint tokens. I think it's actually etch, how you etch tickers. I think that's the appropriate terminology. And then how you mint those tokens. So you can etch, you can mint, you can transfer. That's essentially what you can do with runes, and that's it. Um, and then ordinals is essentially, store images, connect to a SAT. So more like a non-fungible token protocol, but people are storing JSON on ordinals as basically like fungible token actions. And so you can do ticker deploys. So you can deploy a BRC20 token, you can mint a token, you can do like a fair mint where like it's free for all. Anyone can kind of jump in and mint the token. You can do, let's see, you can transfer, you can mint, you can deploy. That's basically it. So both protocols are fairly limited in terms of what you can do on the DeFi side. They don't have like crazy things built in for, I don't know, depositing liquidity into a AMM or into a, doing a buy or sell order in a DEX or something like that. And so a lot of people have tried to make improvements on BRC20 and runes. I could probably name 30 different protocols, fungible token protocols that are trying to improve on what BRC20 and runes kind of laid the groundwork for. Um, I did recently tweet out like my tiering for meta protocols, and I put runes, BRC20, and ordinals as tier one. They're all pretty close to $1 billion market cap, $1 billion plus. I don't think any other meta protocol, even Counterparty, I don't think is $1 billion market cap. I have a couple people in my DM saying it is, so I'm doing a little bit more digging there. But I don't think anything else is tier one. So these are kind of the tier one meta protocols. I know that Domo and the Layer One Foundation and Unisat and Best in Slot are working on upgrades to the BRC20 protocol. They have one called the Swap module, which is pretty cool, and then there's another one called the, well, I call it BRC20 2.0. BRC20 2.0 is basically a way to add EVM smart contracts. Those are the smart contracts on Ethereum into BRC20. So you could actually like inscribe a Solidity smart contract from Ethereum onto Bitcoin and then use it for your BRC20s. And that's kind of the new trend on the meta protocol side. There are a lot of people adding additional programmability to these meta protocols using EVM, Solidity smart contracts, state machines, other kinds of programmability backends. So that's basically the difference between BRC20, Ordinals, Runes, as well as a little bit of flavor on the smart contract side. How people are trying to add more programmability to these meta protocols. What else? What else do you all want to dive into? We could talk about the downsides or the dark side, as I like to say, the dark side of meta protocols. We could talk about Bitcoin sidechains. We could talk about fractal Bitcoin. I know a lot of people are pretty hyped about fractal right now. We could talk about rollups. We could talk about L2s. We could talk about interesting applications being built on Bitcoin. Um, all right, feel free to chime in. People listening, happy to dive in, answer questions. So first, fractal Bitcoin. Fractal Bitcoin, the best way to talk about it is like BSV. It's like a Bitcoin fork. Take all the Bitcoin code and fork it and create a new blockchain, separate token, separate proof of work. Let's merge mine it. So it's a Bitcoin sidechain, different from Bitcoin completely. You can't, interoperate directly with Bitcoin. It's from the Unisat team and the Unisat Worlds team, and they essentially created a new faster version of Bitcoin. So take BSV, take Bitcoin, smash them together, and you have fractal Bitcoin. You have to bridge your assets there if you want to go from Bitcoin to fractal. It's a separate token. They have fractal Bitcoin FB. They have separate assets, separate NFTs, separate tokens, separate everything. They do merge mine with Bitcoin every third block, but otherwise it's completely separate blockchain. They don't really inherit much of the security or decentralization of Bitcoin. So I view it more as like I don't know, like a degen chain, basically. It's a separate chain. I mean, we should probably compare Fractal to like Solana. Solana is almost as much Bitcoin as Fractal is. I mean, I'll put an asterisk there. That's technically not true. Like because Fractal shares code base and is merge mined, and has a lot of similarities and is UTXO based. It means Fractal Bitcoin is more Bitcoin than Solana, but not that much more Bitcoin. So that's Fractal Bitcoin. A lot of people are doing lots of things on Fractal. They're minting Fractal tokens, they're minting Fractal NFTs, they're minting all kinds of things. People are building wallets and marketplaces and lots of infrastructure happening there. It's a nice degen scene if you want to go in and start mining Fractal Bitcoin or speculating on some crazy Bitcoin sidechain assets. So that is Fractal Bitcoin. I'm happy to dive in deeper there. From what I understand, some people are critical of using Bitcoin in different manners, ordinals, etc. Yes, there are people that are very opposed to using Bitcoin in this way. If you and this debate is not new. I mean, we could go back to 2010, 2011, like the earliest days of Bitcoin, and people were debating about what Bitcoin should be. Should it be a store of value, medium of exchange, or should it be the world's most decentralized secure database? Or, can we actually do things on Bitcoin? Can we deploy smart contracts on Bitcoin? And so I think this has always been a debate. What should Bitcoin be used for? I think that in its most simple form, Bitcoin is the most decentralized, censorship-resistant blockchain on planet Earth. And any group trying to tell another group what they should or shouldn't do on Bitcoin, it just feels kind of ironic to me. Like, sure, you can try to restrict the way that people are using Bitcoin, but I mean, Bitcoin is Bitcoin because anyone can use it for whatever they want, as long as you're willing to pay the transaction fees for your Bitcoin transactions. And so a lot of people want to keep Bitcoin kind of pigeonholed in this store of value, medium of exchange use case. I think a lot of people come from like a kind of an economic background where they view Bitcoin as this solution, this monetary solution for the world. If you look at inflation, hyperinflation across the world, if you look at kind of the problems with currencies controlled by centralized governments, you start to see that you have this very centralized control over the monetary supply across the world, and they view Bitcoin as the solution to this problem. Now, if we start, storing images on Bitcoin, actually puts their vision at risk because now we're storing assets, we're storing, fungible tokens, we're using up block space, and that is a potential risk at potential risk to this other vision of like solving the world's monetary crisis, essentially. And so that's the way that I understand it. I really like the fact that we're starting to innovate on Bitcoin again. I think that people are talking about upgrading Bitcoin with OpCat. I think that we should upgrade Bitcoin with OpCat. I think it makes Bitcoin better for everyone. Everyone trying to build on Bitcoin, I think it's better if we have OpCat. OpCat is a simple opcode that enables concatenation and would benefit a lot of people building on Bitcoin. So those are my thoughts on people trying to criticize what's happening on Bitcoin right now. Also, I would say I think this perspective is mostly the minority at this point. There are a lot of Bitcoin maxis who have this view, but the Bitcoin maxi uh, handle over the current narrative on Bitcoin, I think, is diminishing. Like their role is lessening in some fashion. With this Bitcoin season two, we're seeing a lot of new interest and excitement from builders, VCs, developers, users, and because of that, I think those voices are becoming more prominent, and the Bitcoin maxi stance is becoming a bit less prominent. All right. Next question. What does Bitcoin L2 mean? Is it like being able to build apps on Bitcoin directly, or do you utilize Bitcoin? So uh, there are two paradigms to scaling blockchains. One is the monolithic thesis. The monolithic thesis is this is like Solana. Let's build the fastest single-threaded blockchain we can possibly build. That's Solana. We don't need L2s. We're just going to build a really, really, really fast L1. The modularity thesis is the other end. So instead of the monolithic, it's the modularity thesis. And the modularity thesis says we should have a settlement layer. We should have a, like a data availability layer. We should have a batching process like a sequencer. We should have a prover. And by separating out the layers, people can specialize in the individual components, and then you can put those all together into your final blockchain. This is the modularity thesis. So if you look on Ethereum, you have Ethereum as kind of your base layer, your data availability layer, your settlement layer, and then you have sequencers and you have provers that basically interact on an L2. So an L2 is a separate blockchain. You hold on just a second. Just had to chat with my 3-year-old really quick. So an L2 is basically a separate blockchain that is trying to inherit the full security and decentralization of the underlying L1. And they do this by users go onto the L2, they make a whole bunch of transactions, you batch those all together into a big batch, and you send them off to a prover. The prover is essentially going to prove that all of the computation was done correctly. And then you're going to take all the transactions and the proof, and you're going to put it and store it on the L1. So in the Ethereum case, you're going to take these transactions. Normally, it's like a state diff. And you're going to take that with the proof and store that on Ethereum. And then Ethereum is going to verify the proof. So instead of Ethereum having to do all of this computation, instead Ethereum just has to verify that the computation was already done correctly because they have a proof that it was done correctly. And as long as you have the inputs, which is the state diff and the proof, you can prove that it was all done correctly. So in this manner, you don't actually need to do all the compute on Ethereum. Instead, you can do all the compute off-chain in this L2, and then you can verify that it was all done correctly on Ethereum. So you get a nice set of scaling properties here. You get more scale, you get more throughput, you get cheaper costs by doing this L2 model. You can actually do trustless bridging in this way as well. Leveraging the fact that Ethereum can actually verify these proofs, it means that you can create a trustless bridge from Ethereum to an L2, like Arbitrum or Optimism or zkSync or Base. And so this is the dream of the modularity thesis. Let's create an extension of the base layer that inherits the full security and decentralization of the underlying L1, and you can trustlessly bridge to and from the L2, and it's just like this seamless extension of the base layer. That's the dream of the modularity thesis. In practice, it's actually really hard to do something like that, and you end up with a whole bunch of points of centralization. For example, all of the L2s right now still have centralized sequencers. Centralized sequencers, basically the sequencer is everyone that transacts on the L2 is submitting their transactions to the sequencer. The sequencer packages them all up, sends them to the prover, who does all the compute and gives you the proof, and then you submit that to Ethereum for the L1 to verify. The downside of this is now you have an intermediary, the sequencer, that can actually censor your transactions. They can't steal your funds, they can't, forge your signature or anything like that, but they can censor your transactions. And so you do end up with a couple of, it's not a true L2 would be this trustless extension of the base layer, but we're actually not there yet in crypto anywhere. So that's how you do it on Ethereum. When you come to Bitcoin, it becomes even more complicated because Bitcoin can't verify proofs right now. It's impossible for Bitcoin to verify ZK proofs. Some people have started to do it on Signet using CAT, which is pretty interesting. And this is what a lot of the L2s are working on the Bitcoin side, is they're trying to create a trustless extension of the base layer in a more programmable, faster, higher throughput L2, where you can inherit the full decentralization and security of the base layer in faster, cheaper, more programmable space. So this is what Bitcoin L2s are trying to do. We don't have any true L2s on Bitcoin right now. We have a lot of people trying to get there. Some people are actually trying to get there, and some people are content to just be kind of side chains, or even to be like Ethereum L2s that are, have Bitcoin superpowers. So this is what people mean when they say Bitcoin L2. Most people, when they say Bitcoin L2, they just mean Bitcoin layer. Bitcoin layer is just, it could be a side chain, it could be a meta protocol, it could be an L2, it could be, maybe something that just like posts state commitments back to Bitcoin as kind of like reorg resistance or something like that. But this is what people are trying to do on Bitcoin. It is very hard. Hard because Bitcoin can't verify ZK proofs. We need an upgrade with OpCat in order to enable us to kind of have the recursive covenants and be able to have the expressibility on the base layer, to be able to actually verify these proofs. So I know that was a really long-winded explanation, but we had to kind of go back to the foundations there to kind of build up. How long have I been into Web3? Full time since 2021, but was following along since probably 2017. But yeah, I mean, this is my passion, my hobby, you could say, is all of my Twitter content is just deep diving on various cool Bitcoin sidechains, meta protocols, layer twos. So lots to learn for sure. Notable Bitcoin L2 projects. I'll just type them in the chat. You have TonicLabs, you have Citria, you have BitLayer. These are all of the ones that are actually doing BitVM 2 style bridging. BitVM is a way to do compute on Bitcoin. BitVM 2 is a newer model that's better than the old one. And these are the three that I know of. I think there's another one. Bitcoin OS / Sovereign team is also doing BitVM bridging. So these are the maybe 4 teams that are trying to push hard on trust minimized bridging. Trust minimized is not trustless, but it's trust minimized, meaning you trust one out of many verifiers. So those are 4 projects that are doing interesting things on the BitVM side. But on the L2 side, I mean, there are a whole bunch of others. Botanics is an interesting one. That's a spider chain, so probably closer to a Bitcoin side chain than it is a Bitcoin L2. But interesting kind of multi-sig of multi-sigs bridging model. There's also people like Bison Labs. That's an early Bitcoin startup lab company. Just added EVM. There are also people like Merlin. Merlin arguably has the most liquidity, most TVL. They came out with like a blast blur token points model essentially. So they got a lot of people to come and stake their assets to earn. It's essentially to farm Merlin. Some people had a bad experience. Some people had an okay experience. And so Merlin is not. There are a lot of blockchains building on Bitcoin. The best source is probably bitcoinlayers.org. This is probably it's the most fantastic resource. The Bitcoin Layers team is super solid, collaborating with a lot of people in the Bitcoin ecosystem. And you can see a lot of projects in the Bitcoin L2 scene and their risk assumptions, essentially. So who else didn't I talk about? Let's see, Bob, that's an interesting one. It's an Ethereum rollup. It's an L2 on Ethereum, but they're adding Bitcoin superpowers essentially. Core is another one. Um, Internet Computer, that's not a Bitcoin L2. It's more of a Bitcoin sidechain. But again, like decent trust review there. Libre Lightning Network. Interesting things happening on the Lightning Network with like Taproot assets. You are fairly limited on the programmability side, but still interesting. Liquid, Mercury, there's Merlin, Nomic, Rolux, Rootstock, and Stacks. Yeah, so Rootstock been around for a long time. Stacks been around for a long time. Stacks also just did the Nakamoto upgrade. So Stacks blocks are going to be faster. Stacks is a Bitcoin sidechain, but blocks will be faster. And I believe they're releasing SBTC, which is their version of Wrapped Bitcoin. So that's the breakdown on all things Bitcoin layers, essentially. If you go to all, then you can get a whole bunch that are still under review that just haven't been reviewed yet. A lot of things are still being built, and a lot of things are still kind of being reviewed. And so, but this is a really, really fantastic resource. Lots of people put together things like this. This is the one that I would trust the most. What is the Lightning Network? The Lightning Network is a state channel based system for trading Bitcoin. Essentially, on the Bitcoin base layer, you can commit funds to a Lightning channel. So you lock up your Bitcoin and then you commit those funds to a Lightning channel. So imagine now you're on a different layer. You're not on Bitcoin anymore, you're on Lightning. Now we can send Bitcoin back and forth really, really, really fast, like 1 second or 2 second transactions. And so it's really, really, really fast way to send Bitcoin. And as long as there's liquidity in the source channel, the from channel, then you can send Bitcoin back and forth. It is a state channel based system, and so you do have to have channel liquidity, and you also have to have a route. So if I wanted to pay you, I would have to connect to someone that's connected to someone that's connected to someone that's connected to you, and then I could pay you through the Lightning Network. So you would need to have some kind of channel setup. A lot of people just use custodial Lightning setups. That means you leverage an existing provider that already has a lot of liquidity in their channels, and you just go to them and say, hey, I want to pay someone, and they have lots of connections, and so it kind of facilitates things on the Lightning Network side. And so a lot of the existing wallets or implementations on the Lightning Network side are custodial, but you do have really great security guarantees as long as you are monitoring your channel closely. So if you do it in a non-custodial fashion, you have to make sure that you're always there to monitor your channels to prevent anyone from doing bad things to your Bitcoin. In the event that you do trust a custodial provider, then you're essentially just trusting that they will manage your channel appropriately. And I'm sure that they have a lot of like automated mechanisms in order to ensure that people don't steal your Bitcoin using a fraudulent claim. So that's the Lightning Network. It's been around for quite a while now. And people are trying to start to like, how can we put stable coins on Lightning, or how can we put fungible tokens on Lightning? And that's what like Taproot Assets and the TonicLabs team are trying to do. So that's the Lightning Network. Arguably the closest thing we have to a Bitcoin L2 right now. You'll notice on the Bitcoin layers side, Lightning gets all green. And that's because it's a very trust minimized way to move your Bitcoin quickly. So that's the Lightning Network. There are still some risks associated with it, like I mentioned, but that's the Lightning Network. Yes, there are Bitcoin test nets. There's one called Signet. Signet actually has OpCat on it already. So there's Signet. There's also testnet 4 and testnet 3. And I know there are a number of different Bitcoin testnets. I think testnet 4 is probably the best Bitcoin testnet right now. Testnet 3 hasn't been reset in a really long time and is a little bit clunky and hard to use. So maybe use Bitcoin testnet 4 if you're going to use a testnet. What is CAT? Okay, this is probably our last question. I think we're pretty close to time. CAT is an opcode originally in Bitcoin used to concatenate, which is just a fancy word for join. OpCat actually used to be in Bitcoin in the early days. Satoshi actually removed OpCat from Bitcoin because of some DDoS concerns. There are now script limits in Bitcoin, so there aren't really any DDoS concerns anymore. So OpCat just enables concatenation of two items on the stack. You can basically just smash them together. And it sounds very simple, but that simple act of concatenating items on the stack actually allows you to do all kinds of crazy things on Bitcoin. So the Taproot Wizards, the Quantum Cats, these are the people pushing for OpCat. And I think, if I said this before, but I think OpCat is good for everyone. I think as an opcode for Bitcoin, it makes building on Bitcoin better for everyone. So that's CAT. Okay, really quick. The minting price of Ordinals seems generally very high. Yeah, this is because we're storing the images 100% on chain. On the Ethereum side, you're going to mint a token. That token is just going to be like a URL pointer to an image off chain. And so the minting price of Ordinals is very high compared to minting tokens on ETH. You could just mimic the Ethereum model and just inscribe a pointer on Bitcoin that then points somewhere else. But the whole point of Ordinals is like this permanence, being able to actually have your full token plus your image plus your metadata all on chain. You get kind of like digital artifacts rather than just NFTs or more temporary NFTs. So is it going to get better with time? No, it will probably get worse with time. In fact, right now is the cheapest time to inscribe on Bitcoin. If we look at the mempool right now, we're currently sitting at 5 sats per VB, but around 3 or 2 isn't crazy. This is the cheapest it's going to be to inscribe on Bitcoin because fees will likely just go up over time. At least that's what we're all betting on. And so it will likely get worse over time. And now is actually a really good time to inscribe on Bitcoin if you can create really, really small assets. Pixel assets, SVGs, vector-based artwork, or programmatically generated art using code. Those are some of your best bets to get small assets on Bitcoin. So yeah, this has been a great deep dive. I know we've covered a lot here, all the way across the Bitcoin space. Hope it was helpful. If you do have additional questions, again, I'm just at Bob Bodily on Twitter, Telegram, Discord. Feel free to reach out, especially if you're leveraging ICP. I help people all the time build Bitcoin tech on ICP, so would love to be involved.
Well, great. Thank you, Bob, for the extensive Q&A. Thank you everyone else for attending as well, and make sure you tune back in at the same time on Thursday for developing runes on ICP.